Hello again, this is Mr. Carr, and we are going to wrap up our quick little video on slope with part 2. Now we're going to be looking at what if we don't have coordinates written on there. Okay, so what we're going to do is we're going to put a line with a slope of 1 over 2 on this coordinate grid. So we're going to begin by plotting the point 1, 3. From point A, let's do a rise and run for the slope that is 1/2. So that is up 1 to the right 2. So this is A and this is B. So we'll connect those and we have straight as possible, a straight line, and we'll put arrows on the ends of those. Okay. The order pair for A is 1, 3. For point B, it's 3, 4. All right, so what we saw from the graph was we started with this point and we applied the idea of slope to get to this part, the question, point B. Now that we have these 2 points, let's look at something a little bit different. We're going to find the difference in the y coordinates. Okay, so if I look at y1, and that's going to be this one right here. Okay, so that's going to be 3. We decided that this is going to be x1, y1, x2, y2. Now the reason we use these, they're called subscripts with the 1 and the 2 here. We don't want to call these things the same y because we want to make sure that we're distinguishing the one y value is different from the second y value. So that's why we're labeling it as y1 and y2. So for point B, y2 is going to be 4. So we're going to subtract y2 minus y1, which equals 1. Well, let's go back to my graph real quick. How far up did I have to go to get from point A to point B? I went up 1. So this is my rise. We can find rise by doing y2 minus y1. If I subtract the 2 y values, if all I have is a coordinate pair, I can subtract them and get the rise value. We're going to do the same thing with x now. x1 is 1, x2 is 3. When I subtract these two, 3 minus 1, that's 2. And again, when I look at here, it's going 1, 2. So it does match up. This is how I get my run. I do x2 minus x1. This is all leading into the slope formula. Slope, which is rise over run, is the same as taking y2 minus y1 divided by x2 minus x1. And again, the reason why is because y2 minus y1 is showing the rise, which is another way of saying the change in y. And x2 minus x1 is the change in x. So here's what we're going to do. We're going to practice these. I'm going to do the first 2 as an example, but then you're going to try the next 4 in the play pause it here. So in this scenario, and really it doesn't matter which one, and I'm going to help demonstrate that between A and B here. Well, yeah, I'll just demonstrate on A. So if I look at y1, and let's say I do this, x1, y1, x2, y2. Okay, so y1 is 5, y2 is 9, x1 is 1, and x2 is 2. So I'm going to subtract the 2 y values. If I do y2 minus y1, that's 9 minus 5, 2 minus 1, 4 over 1, which is just 4. Let's pretend I switched these. What if I didn't label it like this? And what if I did, it as x2, y2, x1, y1? Well, then I would do 5 minus 9, 1 minus 2. 5 minus 9 is a negative 4, 1 minus 2 is negative 1, and I still get a positive 4. So it doesn't matter which point I want to kind of call my starting point. All that matters is I need to be consistent. I want to make sure if I'm labeling it, it's an x and a y. So that's why it's an x1, y1, x2, y2. So just make sure those numbers match up. All right, one more example. So if I do y1 is 4, y2 is 1, x1 is 2, and x2 is 1. So 1 minus 4 over 1 minus 2 should be my slope here. Negative 3 over negative 1, which is the same as positive 3 over 1. And there it is. There's my slope. So I'm going to pause here and let you try these two, followed by these two. All right, and now that you're back, hopefully you recognize on this one, so that y2 is -2, y1 is 0, x2 is 8, x1 is 4. So -2 minus 0 over 8 minus 4 is going to give me -2 over 4, which is a -1/2 for its slope. Next one here, I've got y1 is 6, y2 is 4, x1 is -8, x2 is 3. So I'm going to have 4 minus 6, 3 minus a -8. So that 4 minus 6 is a -2. 3 plus 8 now is 11. So there's my answer is -2/11. That's it. Okay, next one down here. y1 I'll make -5. x1 is -3. Okay, y2 is -2, and then x2 is -1. So -2 minus a -5 over -1 minus a -3. This turns to addition. So -2 plus 5 is 3. This also turns into addition, so -1 plus 3 is 2. And there's my slope is 3 over 2. And last one of this, I'm going to go ahead and do, let's see here, 0, 7, 5, 0. So 0 minus 7, 5 minus 0 is my denominator. So a -7 and a +5, and that's it. That's all I could do. -7 fits here. Okay. As we mentioned about slope, this is a measure of our steepness, but it's also steepness and direction. This is telling us a rate of change, and I've used that before. So we look at this one. Todd has 5 gallons of gasoline in his motorbike. After driving for 100 miles, he had 3 gallons of gasoline left. The graph below shows Todd's situation. So if I call it point A and point B, coordinates of point A are at 0, 5. Point B is at 100, 3. So the slope of this line, let's find this. So I'm going to do 3 minus 5, 100 minus 0. So 3 minus 5 is a -2 over 100, which is, I want to write it in fraction form, so that's going to be -1 over 50. So we're going to write this what's called a unit rate. The unit rate, excuse me, the unit rate is going to be kind of telling us gallons per mile. So right now, what we have is we're losing 1 gallon per 50 miles. That's usually not what we want to do on this one. We usually, let's see here. Yeah, we want gallons per mile. I had to make sure on that one, not miles per gallon. Okay. So if I want to get my gallons per mile as a unit rate, what I'm going to really do is I just need to get it down to a denominator of 1. So I'm going to just go ahead and take -1 divided by 50 here. All right, if I do that, that should be negative point, let me double check here. Excuse me. Let's see here. 50 won't go in that. Negative 0.02 gallons per mile. So all I did was I just divided it out because technically this is the same as negative 0.02 over 1. So -1 over 50 is the same as negative 0.02 over 1. So that's where we're getting our answer from. Okay. So, unit rate. Rate is a ratio that compares 2 units of measure. So we can use this in a variety of ways. You saw right there gallons per mile, but maybe I do something like this, dollars per hour. Okay, you can rename rates like you rename fractions. So in this example, divide the numerator and denominator by 10. So instead of saying we get $170 for 20 hours, we can instead say $17 for 2 hours. But again, we can want to divide that out because if I divide both the numerator and denominator by 2, I get it like this. 17 over $2 per 1 hour. And that's our unit rate because 1 is in the denominator. And we don't normally talk like this, so we just turn 17 over 2 into $850, 850 per hour is the idea. Okay? And that's the idea of our unit rates. We want to try to simplify it into something over 1 so that it's kind of like helps with comparison and it's more clear about that, what the idea of that rate of change. All right. So I'm going to leave this one for you, and I'll just leave this as the final thing for you to do in the play posit, and we will discuss it during our Zoom. So I will talk to you later on this one. All right. Have a good day.